Hello, and thank you so much for your interest in Bubbln, a ChatGPT powered network automation tool that makes use of APIs to prompt ChatGPT to generate ansible codes, which are then used to automate a network. Bubbln aims to simplify how networks are being provisioned by changing the high technical skill requirements to mere data input skill requirements, thereby increasing productivity for network engineers and reducing deployment costs. This is my master's degrees at Birmingham City University, and my name is Olasupo Okunaiya. In our previous videos, I got feedback that the prompt that was used to generate the ansible playbooks was not visible, and that is why we're making this video where we will be making intentional errors during data input, and then we will use natural language to prompt ChatGPT to make corrections to the playbook. So we will be automating this network as usual on the left here that was built using the Cisco modeling labs, and as a result that means we have the G1 interfaces already pre-configured. Other than that, no other thing has been configured, and we can confirm that by logging into the routers. We are now in the console for router 1. Do show IP interface brief, where we can see that just the G1 interface is configured, and for the routing protocol, none is currently configured. Also for the router 2, do show IP interface brief, okay, confirms that just the G1 interface is currently configured and no routing protocol configured. With that, we move into Bubbln, initiate it, and the very first time Bubbln is initiated, it introduces itself and its capabilities. After that, we are then required to input the configurations parameters for the routers, and in this case we have two routers to be configured, and further request for parameters for router 1 is being requested. So we have three interfaces to be configured, the two loopback interfaces and G6 interface. So we put in 3 here, and number of protocol 1, OSPF, area 1, ID 1. And like I mentioned earlier, we will be making intentional errors in our configuration input. So enter number of networks to advertise, that's going to be 4, and network address, let's say the first one, which is supposed to be 10.10.175, okay, .175, let's say 10.10.20.190/1020. The other one, which is supposed to be 190.168.6.1, let's say .220.1/28. okay, then the third one, just any values, 210, and the last one, let's say .8.1/15, just something. Then loopback 0 should be, let's say, loopback 90. Then we give this IP address 220. Loopback 1, which is would then be let's say loopback 87, just something. Then this will be 210, and then G6 will then be, say, G9, okay, and the IP will be 8.1 here. So we're done with router 1. We'll input the correct configurations for router 2 just to save us some time, okay, and then ID 1. Number of networks to advertise will be 4, that's 10.10.20.176/24, 192.168.30.1/24, and then the third one is 40.1/24, and finally we have 30 here and 2.2. okay, loopback 0 will be 30.1, loopback 1 will be 40.1, and then G6 would be 2.2. Okay, so we are done with data configuration. This is the first checkpoint to ensure that our parameters are correct, but we'll not be using this Bubbln built-in checkpoints. Instead, we'll be using the second checkpoint, which is the ChatGPT checkpoint. So with this, what Bubbln does is it takes in all the input parameters, all the configuration parameters that we just imputed, and then use them to generate a prompt, which is then sent over to ChatGPT, and then ChatGPT makes use of that to generate the required ansible code to be executed on the network. So when ChatGPT generates the code, it sends it back to us, and then we then get to the second checkpoint where we ensure that the playbook meets the needs, meets the requirements of the network, and that is the second checkpoint. That second checkpoint is what we will leverage to make changes to the configuration error. So the playbook looks good. The indentation seems to follow the YAML structure rule, and the iOS config module is used, and the parents configuration, the parents argument is implemented for the different interface and OSPF configurations. So the only thing that appears to be wrong here is the configuration parameters, which we will correct now by imputing a new prompt. So we will say, please replace loopback 90, loopback 87, and G9 with loopback 0, loopback 1, and G6, and assign IP address 192.168.6.1/24, 192.168.0.1/24, and 192.168.2.1/30 respectively. Okay, and ensure no interface is shut down. All right, so that does that. Also also ensure the advertised interfaces, advertised networks reflect the corrections made to the interface IP addresses. Okay. Also, do not exclude please ensure 10.10.20.190 slash 10.10.20.175/24 is included in the advertised network, advertised in the advertised networks. Okay, using the correct wild mask. Or maybe we say please retain to reduce complexities. Please retain 10.10 this in the advertised networks. Okay, networks. All right, so with that, we click on enter and then wait for the playbook to be generated for the corrections that we just made to the network. Okay, so we now have a response concerning the new playbook, and we can see loopback 0, we have this IP address correctly configured, and for this as well, we have the IP address correctly configured, and for interface G6 also we have that correctly configured. So, and the corresponding networks were also correctly configured with the 10.10.20.175 included. So this looks good. We then ask Bubbln to execute this on our network. Before that, let's ensure we're in the console for router 1 so that we can see the log of the execution process. So first, Bubbln logs in, which has occurred here successfully. After that, it configures the loopback 0 interface. Okay, configured. We also have loopback 1 configured and it's up. All right. So next we will have the G6 interface configured. This has been done here and it's up. So also the OSPF has been configured and Bubbln has exited the router here. So next, the playbook for router 2 is being generated, and while that is going on, let's confirm the configurations that we have made through Bubbln. So show IP interface brief, we can see that loopback 0, loopback 1 and G6 interface have been accurately configured with the IP addresses we want. And finally, do show IP protocol also shows us that we do show IP protocol also shows us that OSPF has been accurately configured with the network addresses that we require. So next we go into the console for router 2 to monitor the configurations as they are being executed. This playbook also looks good. The parameters appears to be correct as well. So we'll just go ahead and execute it on the network. So yes. So first again, Bubbln logs into the router 2, which is here, successfully logged in. Then next it's going to configure the loopback 0 interface, which was done here. Okay, and then loopback 1 interface correctly configured here and it's up. Next is going to configure the G6 interface and ensure that it is not shut down, and that is done here. Okay, so and the interface is now up. Next is going to configure OSPF, which has been done, and we can see that OSPF adjacency has been established and the state of the OSPF has been changed from loading to full. So with that, the configuration is done and Bubbln has exited the router. So next we will just confirm the parameters. Okay, show IP protocol shows the routing protocol configured correctly. Show IP interface brief also shows us that the interfaces were configured as required. So we can then use show IP route to confirm that from router 2, the expectation is this loopback interfaces should be discovered through OSPF, and that is exactly the case. 192.168.0.1 and 192.168.6.1 were discovered through OSPF. Also, going into router 1, the expectation is these two loopback interfaces should be discovered through OSPF, in router 1. So show IP route, we can also see that the protocols 192.168.30.1 as well as 192.168.40.1, were also discovered through OSPF. And both routers can reach all the networks that are configured on our network. With that, we have been able to show that Bubbln is an effective tool in implementing network deployments and simplifying how network deployment can be done. Thank you so much for your time. This is really appreciated. Thank you. Bye bye.